So now let's talk about confidence intervals for proportions. And when I say proportions, all I'm really meaning is that I'm talking about percentages or fractions. Most of the time, you will see a lot of stuff about proportions. It's in our news every day. Think about like during the election year, they'll show the confidence intervals in terms of proportion and percentages. So, for example, a poll for a candidate running for president might show that that candidate has 40% of the vote within 3 percentage points. And that again is if the sample is large enough. If they say that and the sample is, say, 50 people, that's not good. So think about if you watch election night, they'll give who's winning by percentages, but then they'll also show of the polls reporting. And that has to me a bigger impact than what candidates' percentages are, because that's showing you how much of the sample is included in that percentage. So think about it as the percent is that as more polls start reporting and that number gets bigger, the accuracy of the candidates' percentages increase. And that's how they do election night. As you can see, you have to be careful when you watch first part of the night because it may give you a result that doesn't happen. So often election polls are calculated with a 95% confidence. So the pollsters would be 95% confident that the true proportion of voters who favor the candidate would be between 0.37 and 0.43, which basically is 30. Their candidate would be between 37 and 43%. So that's what we're talking about. Again, we're not given that true estimate of the percentage. We're given a range, and a range can cover you in a lot of different circumstances. All right, so the procedure to find the confidence interval, the sample size, the error bound, and the confidence level for proportion are very similar to that from the population mean, but the formulas are different. Remember when we knew the standard deviation and we used all the Z stuff? We can kind of do that again. And that rule is based on that we're looking at the underlying distribution of a binomial distribution. Remember, for binomial, you don't have a mean or an average, but what you have is the percentage something will happen. And remember, binomial means you have two events that can happen. So let's say head or tail. So I want to know the percentage of head, the percentage of tail, the number of trials, and then the probability of success. So that's basically what we're doing on that one is we're doing the binomial that we talked about previously, but we're applying it to proportions. So here's the point estimate. Here's the Q. Here's the EBM, which is the error bound of the proportion. And then here is the way that we write it. And I'll come back to this. So, okay, again, here's an example of the confidence intervals and the Z-scores. The wonderful thing is we don't have to do this by hand. Minitab does it for us. And one reason we're using the Z-score is the rule is binomials keep going up and up and up. They start to get that pretty normal distribution curve.